In your manual, please turn to page 122, page 122. And on that page, please execute the commands in the slide at the top of the page. By now you've seen lots of example commands in the gray text boxes in your manuals, and lots of example commands in the slides. All those example commands are in scripts, here in the examples subdirectory. So in the day one folder, if you go to the examples subdirectory, you'll see lots of scripts. How do you know which script contains what? Well, in your manual, in the gray text boxes, if it has # script, colon, and then followed by the name of the script. And that's the name of the script here inside the example subdirectory. As we talked about earlier, the ISE command is short for PowerShell ISE, and that'll open up the script inside of a new tab. You have tab completion, by the way. So if you type in just the first couple letters of the name of the script and hit tab once or twice, it should tab complete to fill in the full name of the script, and then you can open up quickly. PowerShell, by the way, is almost never case sensitive. So you can see one of the scripts is named if_flow control. If you type IF in lowercase or uppercase, it doesn't matter. When you hit tab, it'll tab complete and then show you the correct file name. For the next several slides, we're going to look at examples of flow control keywords. And also, as we were talking about earlier, you can highlight one or more lines of code in a script and then click on the Run Selection button. So just as a reminder, I'm going to switch back to my VM, go to the same example subdirectory as you. Now I do ISE if flow control. So if I highlight one or multiple lines, I can then click on the Run Selection button. This looks like a script with a small green triangle, and it'll execute just that one line. Or if I highlight, let's say, multiple lines, and then click on Run Selection, it'll execute only the highlighted code and nothing else. The output of the command is displayed in the command shell down at the bottom. If you prefer using your keyboard, notice that when you hover your mouse pointer over the button, it shows the keyboard shortcut. In this case, it's the F8 or function 8 key. All right, so page 122 in your book. Please run these commands that'll open up 4 scripts and 4 new tabs. And as I go through the next several slides, you're more than welcome to type in the commands manually, but it's usually a lot more fun to highlight what you want to play with and then click on Run Selection. It also means that you can edit the code in the script. You don't have to save the script. Just edit the code in place, highlight it, and then click on Run Selection, and that's a good way to play around, have fun, and to learn. The keywords are shown in red. They're not case sensitive, even though they're capitalized here on the slide. These flow control keywords allow you to jump over blocks of code that you don't need to execute, or as we're going to see in just a little bit, allow you to execute the same block of code over and over and over again in a loop. A block of code is indicated by an opening and closing squirrely brace, and inside the squirrely braces, you can have 0, 1, or many lines of code. Now, on this slide, each block only contains one line inside of it. That's why I could fit it in the slide. Just keep in mind that in real life, you could have a block of code with thousands of lines. That's perfectly fine. So here's the example. I've got a string inside double quotes, and I'm assigning it to a variable. Now with the if keyword, I'm performing a test. The test is inside parentheses. If the test outputs true, then the following block of code is executed, and none of the other blocks are executed. So only one block of code will be executed. So let's look at the first test. $string. Do the contents of that variable, are they like sans star? And in this case, that would return true because that string does begin with sans followed by, well, anything. A single star here means 0 or more of any character whatsoever. So in this case, this test, it would output true, and you can actually see that. If you go back to your editor, you can highlight those lines, click on Run Selection, and then you can see that it outputs true. I'll do that on mine. So there we go. Here's that first line. I need to fill the string variable with the text. And now what if I highlight just the test and nothing else inside the parentheses? When I click on Run selection, we can see that it outputs true. Now let's imagine that this test outputted false instead. If the first test outputs false, then PowerShell will look for another keyword named ElseIf, and sure enough, it finds it. Because the first test outputted false, and there is an ElseIf, well, PowerShell now executes the next test. What's the difference between the dash-like operator and the dash-match operator? What's the difference between the two? The dash-like operator is for simple wildcards like an asterisk, whereas the match operator, this crazy-looking text right there, that's a regular expression pattern. So now for the ElseIf test, does a string match this regular expression pattern? You might not know about regular expression patterns, that's perfectly fine, but it does match this right here. Because the letters F, G, H inside square brackets in a regular expression pattern means F or G or H. And in this case, GAC matches. Because that test outputs true, PowerShell would execute the immediately following block of code and no other blocks. Now let's imagine that that test also outputted false. So we've had two tests so far, and let's imagine both of them outputted false. PowerShell looks for any more else-ifs, and sure enough it finds one, and it performs another test. And in this case, the test actually will output false, because the string is definitely not equal to just GCWN. What if all three tests turned out to be false? The tests here inside the blue parentheses, imagine all three of them turned out to be false. In that case, PowerShell looks for another keyword, it's the word else. And notice that there is no test after the word else. Instead, what you have is a block of code. The else block at the very bottom is only executed if all of the prior tests return false. So that means when you run the code here in the slide, it's guaranteed that one block of code will be run, and only one block of code. Here's something else too. The keywords ElseIf and else, those are actually not required. And you can do it all in one line if you want to. For example, if I say, is 3 greater than 4, well then have PowerShell say hi there. How come it did not say hi there? Ah, that's right, the test is false. 3 is not greater than 4. That test outputted false, which means that you don't execute the following block of code. There is no ElseIf, and there is no else block either. Now, what if I add an else block? And again, it's not case sensitive, so I should type it in lowercase just so you can see it for sure. So what if there's an else block? There we go. Because the test is 3 greater than 4, nope, that returns false. We skip the first block of code. PowerShell finds the else keyword and then executes the second block of code. So having the else keyword is optional. And having else ifs, like back in the slide, you can have 0, 1, or many of those else ifs. But you don't have to have them if you don't want it. Notice too that to have PowerShell say something, you just put the text inside double quotes, and it outputs that text. It displays it. So this is different. In other programming languages, you might have to do echo say something or print say something, something like that. Nope. In PowerShell, if you create an object and you don't pipe it anywhere else, then that object will be displayed on screen. And in this case, the object is a string object. Here's another one. This is the while keyword. PowerShell can create and manage scheduled tasks. It can also trigger or execute scheduled tasks that already exist. So as an example, I go back to my virtual machine, Start menu, I type in the word task, and I launch the graphical task scheduler application. You don't have to do this on your box, I just want to show. In the graphical task scheduler, I can see that there's already over 100 scheduled tasks from Microsoft. The scheduled tasks are organized into these yellow containers that look like folders. I can right-click and create my own new folder, maybe named Sec505. And inside that yellow folder, I can right-click and create a scheduled task. Now for this one, I'm going to name it SetUID. By the way, we're going to talk more about this tomorrow. For the trigger, I don't define a trigger at all. The scheduled task will never run by itself. And for the action, I'm going to execute a command. In real life, this would be, how about a PowerShell script followed by the path to the script that I want to run. On the Conditions and Settings tab, we have more control over when the task is executed. And the main thing I want to show is this. On the Settings tab, I can check the box, Allow the task to be run on demand. So a scheduled task does not have to be executed on a schedule. We can allow users to trigger or launch a scheduled task that has already been created previously for them. So there we go. I now have a yellow container named Sec505, and I've got a scheduled task named SetUID. It never runs spontaneously, it never triggers all by itself, but I allow users to execute that scheduled task whenever they wish. How do you do that in PowerShell? There's a commandlet for it, Start Scheduled Task. Task path is the name of the yellow container that contains the scheduled task, and of course task name is the name of that scheduled task. On the next line, I get that scheduled task by name because I need an object that represents that scheduled task in its current running state. That object goes into the task variable. So here's another flow control keyword. It's while. While a test outputs true, execute the following block of code over and over and over again. So in this case, we're not going to run that block of code once, but maybe 10,000 times. Every time we loop through, after executing the block of code, we loop back up and then we do the test again. If the test still outputs true, well then you execute the block of code again. So what's going on? Well, we just executed or triggered a scheduled task. Inside the task variable, we have an object that represents that scheduled task. Scheduled tasks have a state property. It's the current running state of the scheduled task. And that state could be running, stopped, pause, or error. So while the state of that running task is equal to running, execute the following block over and over again until that scheduled task is no longer running. So what's going on inside the code? It says task still running, and then, what's this? A plus symbol? Let's talk about it. In PowerShell, the plus symbol has two meanings. So 3 plus 7 equals 10. In that sense, the plus symbol is for arithmetic addition. But notice, if I put 3 inside double quotes and 7 inside double quotes, now the plus symbol means concatenation. Concatenation means take two strings and simply glue them together. So while that might look like a number inside double quotes, that's actually a string with one character, the 3 character. Here's something else. What if I do $x equals getDate? Now getDate, that's not like for eharmony.com or similar. Instead, getDate outputs an object that represents the current moment in time. And that's what's inside the x variable, an object that represents that moment in time in the past, because now that's about 7 seconds ago. But these objects have properties and methods. Like for example, if I wanted just the number of the day, or just the number of the year, or how about if I do add hours? So what is 50,000 hours from now? That is December 18th, 2025. And if you add a negative number of days, hours, minutes, or seconds, well, then that takes you in the past. So 44 hours ago is April 3rd. Now, one of the properties that you have on a datetime object is actually a property named datetime. This displays the date and time using your local language and local preferred formatting for date and time. For example, I'm sitting at a machine in the United States. I have my preferred language set to English, so it's printed out in English, and I have it set to display dates in kind of American format, like April 5th, 2020. But on the other hand, if you were sitting at a machine in, let's say, Germany, then it would output it in German, and it would output the month, day, and year, probably in a different order. It'd be displayed as day, month, and year. So the datetime property will display it in your local language and your local preferred formatting for dates and times. You might say, well, why would I care about that? Imagine you run a script on a machine in Chicago, and then later you want to run that same script on a machine in Tokyo, Japan. Well, when it's run on the machine in Tokyo, you want it to output the date and time in Japanese. But there's a trick. So when the code runs, it says task still running. The plus symbol here means concatenation, but what am I concatenating to the end? It's the date and time in the local language of the machine. But here's some new syntax. We haven't seen this before. Inside the parentheses is a command, followed by period, and then a property or method. This is a way of directly accessing the property or method of whatever is the output of the command. So if I go back to PowerShell on my machine, what if I do this? I could, for example, get the date and time, save it to a temporary variable, and then display the datetime property like this. But I could also run that same command, getDate, and then use this new syntactic trick. I don't need a temporary variable named x. By putting the command inside parentheses, I'm telling PowerShell whatever is the output of that command inside the parentheses, access the datetime property of the output. This technique, by the way, is called grouping. You can group one or more commands inside the parentheses and then directly access the properties and methods of whatever is outputted by the command. So for example, if I do add days, then I could ask, right, what is 505 days in the future from today? Well, that's August 23rd, 2021. Notice I didn't have to hard code that date. And whenever I run the script, it's 505 days from the moment you run the script. Because whenever you run getDate, that outputs an object that represents right now, whenever that happens to be. So this is a very common technique used in PowerShell scripts. You'll see this all the time when you look at other people's scripts on the internet. All right, so what's going on here? I take a string, and I'm concatenating another string to the end of it. But in this case, I'm using the grouping technique to get the date and time in the local language and formatting of the machine. Now the next line, it says start sleep -seconds 10. If I go back to my virtual machine, I do start sleep. I can do seconds or milliseconds. So if I tell it sleep for 3 seconds, notice that my blinking cursor goes to the next line, and then PowerShell appears to hang for 3 seconds. And by the way, you can do a bit of math here. 60 seconds in a minute, 60 minutes in an hour, times 4. In this case, I'm telling PowerShell to sleep for 4 hours. It computes the math inside the parentheses first, and then passes in the total number of seconds. So if you need to run a script as, let's say, a scheduled task, and you need it to do something, and then wait for 5 seconds or 5 hours or 5 days, you can have it sleep for that amount of time, and then continue on. Now, how do I break out of this? I can either do Control-C, or I can click on the red square button in the toolbar, which does Control-C for me. So going back to my script then, I'm telling my PowerShell script to sleep for 10 seconds. While the PowerShell script is sleeping, it does nothing. It consumes almost 0 CPU cycles. In the third line, I get that scheduled task again, and I refresh my voodoo doll, my object that represents that scheduled task. I have to do this because after running these 3 lines of code inside the block, I go back up to the while test at the very top and I do the test again. That's why I have to update the task object. So, is the task still equal to running? Is the state property equal to running? Well, if it is, then it outputs task is still running, displays the date and time, sleeps for 10 seconds, and we do that over and over and over again, maybe for hours, until eventually that scheduled task is no longer running. In other words, for some reason or another, we are monitoring that scheduled task and every 10 seconds printing out task is still running and then the date and time. Finally, or eventually, hopefully, the task is no longer running. So the last line of the script, it says task completed, concatenation character, the plus symbol, and then the date and time is displayed. The main thing to see all of this is that a block of code can be run over and over and over again, potentially hundreds of thousands of times, potentially forever. I mean, if the test inside the parentheses here at the top always outputs true, like is 1 equal to 1, that test will always output true, and that means that while loop would loop forever until you either terminated PowerShell or did a Control-C to stop it. Now for you Linux people out there, you can guess why I named this setuid. What if I had a scheduled task that ran the script as the system identity or the administrator account? I could allow regular users to launch that scheduled task, to run a PowerShell script as system or as administrator, and then the scheduled task completes. This is one of the ways that you can implement something like setuid on Windows. And tomorrow we're going to see another way of doing it. It's with PowerShell GIA. Now be aware, what if there were no scheduled task named setuid? What if that did not exist at all? Well, in that case, I would try to access the state property of an object that doesn't exist. And that means that this test would be false, which means that this block of code would not be run at all. How can I guarantee that a block of code is run at least once? Well, that's what a do-while loop is for. In a do-while loop, you will do the block of code and then you do the while test afterwards. If the while test outputs true, well then you go back up and you do the block of code again. But at least in this case, we're guaranteed to do the block of code at least once. What's going on inside this block? Well, there's a very crude port scanner built into PowerShell named test net connection. You give the target IP address, target TCP port number, and it'll attempt to do a full 3-way handshake. If the full 3-way TCP handshake succeeds, well then, when you look at the result object, you'll see that the TCP test succeeded property will be set to true. So notice, the output of test net connection is saved to the result variable. The result variable has a property, or the object inside of it has a property named TCP test succeeded, and it indicates exactly that. You were able to do a full 3-way handshake. Let's imagine that you've got a web server that just spontaneously fails, but it fails at random intervals between like 3 and 14 days, and you don't know when it's going to fail next. So every 60 seconds, I attempt to connect to port 80. Notice that the script sleeps for 60 seconds with every looping. And every time I test, I confirm that I'm able to access port 80 on the machine by doing a 3-way handshake. But eventually, let's say 5 days later, the web server stops responding. In other words, I cannot do a TCP 3-way handshake with port 80. That means the result variable will contain an object, and that object will have a property, TCP test succeeded, and that property will be set to false. Once that while test is set to false, We don't go back up and do the loop again. We continue on with the rest of the script, and as you can see down at the bottom, it says web server test failure, and then it displays the date and time in the local language. It's using that grouping technique. Here's another flow control keyword. It's ForEach. Now for this, let me demonstrate it live. It makes it easier to understand what's going on. So this is one of the scripts that you have opened on your machine. I highlight these lines and then click on the Run Selection button. Now we can see the output at the bottom. In the output, we have service name, a colon, and then the current status of the service. So what's going on in the code? Well, I get all my service objects and I put it into the services array. And now, for each service in that services array, display the name of that service, concatenate a colon, concatenate the status of that service. Go to the next service in the array and put the next service object into the SVC variable, and then repeat it all again. So if you had a bucket of pennies, you could pull a penny out of the bucket at random, and whatever penny you have in the hand, you could name that Bob. And now we could talk about Bob, like what is the year stamped onto Bob? And is Bob one of those pennies they made in the Second World War that was not made out of copper? And what is the quality or the condition of Bob? But then you throw Bob away. You reach into the bucket, you pull out another penny. But remember, that's the new Bob. Whatever penny you have in the hand, that's Bob. So I named the variable right here, SVC, as a reminder. But I could rename that variable to anything you wish, like for example, Bob. If you do this though, you have to update that variable name inside the block of code. The Bob variable, in a sense, is whatever service object you happen to have in your hand at the moment. And at any given time, you only have one service object in the Bob variable. After you display the name and status of the first service object, you discard it, you then reach into the bucket, in other words, reach into the services array, you pick out the next service object, and then display its name and status. Notice that if I highlight these lines of code and then click on Run Selection, it runs perfectly fine. But naming that variable Bob isn't very helpful. I mean, at least if I name that variable S, that could act as a reminder. What's inside the S variable? Oh, that's right, it's a service object, S for service. But you could name this anything you wish. In fact, I could even name it serve-is. So you could use very long variable names, and in long complex scripts, using nice variable names like this will help you out. Notice that we have to be careful here. We have two variables now. We have service-is, right, with the S at the end, and also just plain serve-is. But also, this will work just fine too. I can highlight the code, and it runs. ForEach can come up in a different way as well. Notice at the bottom of the slide. At the bottom, I run getService, and I'm piping into ForEach. Now in this case, ForEach, this is at the bottom of the slide only, ForEach at the bottom of the slide is an alias for a command named ForEach object. So this is confusing. When the word ForEach appears at the beginning of a line, that's a keyword built into the language. But when you pipe into ForEach, what you're really doing is piping into ForEach object. Here's another difference. When you're using the ForEach keyword, that is followed by parentheses, where you invent a local variable here on the left, and then we have a keyword in. Whereas when you pipe into ForEach, notice that there are no parentheses immediately after the word ForEach. Instead, we have the block of code. I don't get to choose the name of the variable. Instead, I use the default variable, the catcher's mitt, $_. So at the bottom, I run getService. Each of those service objects, one at a time, goes into $_, and I do just as I did before. I display the name, colon, and status of that service object. So that means these two chunks of code do the exact same thing. If I go back to my virtual machine, we can see it. So again, as we've seen several times, I can highlight these lines of code at the top. There's the output. But if I scroll down a little bit, there's that one line, and the output looks exactly the same. Now, if the output is the same, why have two different forms? Why would I prefer one syntax versus the other? Well, two things. First, when you're using this type of syntax, we have the ForEach keyword at the beginning of the line by itself and then these parentheses, you get to choose the name of the variable right here, that temporary variable. And I know for a short little script like this, that's no big deal, but when your scripts get longer, to like dozens, hundreds, and maybe even thousands of lines, using descriptive variable names will make a big difference for troubleshooting. Down at the bottom, I don't get to choose the name of the variable. It's always $_. But there's another difference too. The code at the top will run approximately 10 times faster for a large array than the code at the bottom. And the reason for it is this little pipe symbol. Pipe symbols in PowerShell are expensive. And when you are piping large numbers of objects, like tens of thousands or hundreds of thousands of objects, every time an object has to go through a pipe symbol, it requires lots of CPU cycles. So if you want to optimize the performance of your code, you would prefer the construct at the top. Now, on the other hand, if you're only piping in, let's say, a few hundred or a few thousand objects, well, it's probably not going to be humanly noticeable. And if you want to pipe into ForEach, that's perfectly fine. So technically, it would be slower, but probably as a human being, we wouldn't be able to notice the difference if it's only, let's say, a couple thousand objects. Here's another flow control keyword. It's switch. Here's a PowerShell trick you can see at the very top. I'm setting 3 variables to 0. So whenever you see a line that has multiple equal signs, you start on the right-hand side and you move towards the left. So what happens is 0 is assigned as the data to the paused variable. And the contents of the paused variable, that's assigned as the data for the running variable, which of course is assigned as the data for the stopped variable. And this little trick then sets all 3 of these variables to 0. Now for the switch flow control, after the word switch comes parentheses, and inside the parentheses you can have a command. You could also just have an array right there instead of a command that produces an array. The command is getService. That outputs about 200 objects, and each object, one at a time, goes into, you guessed it, the catcher's mitt variable, $_. And now, the syntax is pretty weird. We have a test, but it's not inside parentheses. It's inside squirrely braces. Now, Microsoft did this to make PowerShell more similar to other languages, specifically Perl at the time. But personally, I think this is a mistake. It makes it inconsistent with the rest of PowerShell. Tests are normally inside parentheses. But in this case, with the switch keyword, you put the test inside squirrely braces instead. So here's the idea. I run getService. I take that first service object and I put it in the catcher's mitt variable, $_. Service objects have a status property, and now I can ask, is that property like running? In other words, I'm doing a test just like we did before that outputs true or false. The test is inside squirrely braces instead of parentheses, but it's the same idea. Now the idea is that if the test outputs true, then execute the immediately following block of code. Now in this case, it's inside squirrely braces and it is a script block. So the test is weirdly inside inside squirrely braces, but that's a test that outputs true or false. To the right of it is a script block, like a normal script block. Now this script block is very short. It's just got one little command. Just know that in real life, you could have a script block with hundreds or even thousands of lines. Remember that we set all 3 of these variables to 0 in the first line. Well, if you have a variable set to a number, like for example, I set x equals 4. If I do x++, that now increments that variable by 1. So we go from 4 to 5. And every time I run x++, that increments the variable again. So I can see after calling that a few more times, x now equals 8. You can do ++ for incrementing. You can also do x minus minus for decrementing or decreasing. So x++ will increase by 1, x minus minus will decrease or decrement by 1. And these are very handy for counters. So going back to the slide then, I already set all three of these variables to 0 at the top. I run get service, and for each service on my machine, if that status of the service is running, I increment the running variable. But if the status is stopped, I increment the stopped variable. And as you can tell, if it's paused, I increment the pause variable. After doing this for the first service, I go back up, I get the next service from the output of the command, and I perform all three tests again. Now once it's all done, I can now output a little report. Services running equals something, and services stopped equals something else. The switch flow control, by the way, has other tricks up its sleeve. They're all listed in your manual. Because of time constraints, we can't go through all the different syntax variations of switch. But be aware that if you're familiar with the regular expression patterns, you can also compare the output of a command against a long list of regex patterns instead. Because many people are not familiar with regular expression patterns, that's just in the manual, and I don't have a slide for it. The switch flow control is actually the most complex of all the flow control keywords. So notice that in this part of the manual, it does go on for several pages.